Next, we discuss the 2's complement representation of integers. So we are discussing 2's complement representation. So this representation is used for integers, positive numbers. They are represented same as in sign magnitude form, but the negative numbers are represented in 2's complement form. So let us see how to represent it. So we will take some examples. Okay, let us suppose that we have to represent plus 7, which is in decimal number system. So we will represent the positive numbers in the same way as they have been represented in sign magnitude form. So we will first write the magnitude in binary, which is 111, and we will put a 0 to indicate that the number is positive. Now, if we represent minus 7, then first we will represent the number in positive form. Then we will calculate the ones complement. How to calculate the ones complement? We will simply invert the bits. So this will become 1000. This is actually known as the ones complement. To calculate the 2's complement, we will simply add plus 1 and we will get the number 1001. So 1001 in binary is the representation of minus 7 in 2's complement form. So this is actually the representation of minus 7 in 2's complement form. Right. So always remember that whenever you have any number represented in 2's complement representation, the first bit is always indicating the sign of the number. So you see that here that the first bit is 1. So 1 indicates that the number is negative. 0 indicates here that the number is positive. So this is actually the first bit, which is actually known as the MSB, most significant bit. This is always indicating the sign of the number, whether the number is positive or negative. Right. Now, what is the maximum number that can be represented using 3 bits? Right. So if we talk about the positive number, so we have only 3 bits. Right. So these two values can be at value maximum 1 and this will be 0 because this is indicating the sign of the number. So what is the magnitude in binary? This is nothing but plus 3. And what is the minimum number? That can be represented using 3 bits. So we know that we have only 3 bits. So these 2 bits can have minimum value 0 and this one will indicate the sign of the number. So what is the value of the number here? This is 1, 2, and this is 4. So this is nothing but value minus 4. This is in decimal number system and this is in decimal number system. So using 3 bits, the range of the numbers will be minus 4 to plus 3. Right. So similarly, we can calculate the range of the numbers using n number of bits. Now we will discuss the properties of 2's complement representation method. So we are discussing the properties of 2's complement representation for integers. So what are the different properties? So properties of 2's complement representation. So what are the properties? The first property is that sign extension property. It means we will see that the sign of a number can be repeated on the left side up to a particular number of bits. So that is actually known as the sign extension property. The second property is shifting a number by k bits to right will divide the number by 2 की power k. Similarly, shifting a number by k bits to left will multiply the number by 2 की power k. The fourth property is that 2's complement of a number is negative of that number. The fifth property is that it has only one representation of 0. Right. So we will see each and every property one by one. So this is nothing but 2 की power k. This is nothing but 2 की power k. So first property is the sign extension property. Sign extension property says that if I have a number minus 7 in decimal, so we have seen the representation of this number, right? So the representation is 1001 in binary. So this bit indicates the sign of the number. So as the number is negative, this bit is set to 1. So I can towards left, I can repeat this sign bit in number of times. And if I repeat this, the value of the number will not change. So if I repeat this once, so it will become 11001. The value of the number still remains minus 7 in 2's complement form, right? Or if I repeat it two times, still the value of the number does not change. So this is actually known as the sign extension property. Even if I have a positive 7 number, so positive 7 is represented by 0, 1, 0, 0, right, in binary. So I can repeat this sign bit. So if I repeat this sign bit, this is my number and I am repeating this sign bit, the value of the number will not change in 2's complement form. I can repeat it any number of times I want to repeat it. So here I am repeating two times, here I am repeating only one time. Still the value of the number is plus 7 in 2's complement representation. So I can repeat the sign bit towards left any number of bits. This is actually known as the sign extension property of that number. Now we will see the another property which is the representation of 0. So how do we represent 0? Positive 0. Let us suppose that I am using 4 bits. So first bit will indicate the sign and rest of the bits will indicate the magnitude in binary. And how do we represent minus 0? So we will calculate the 2's complement of plus 0. So calculating 2's complement of plus 0. So what will be the 2's complement of plus 0? This is 1's complement. And if I add it 1, so this will become 110, 110, 110, 110, and this is 1. Because I am using only 4 bits, so this 1 will be discarded, right? So this is nothing but plus 0. So that's why the 0 has only one representation in 2's complement format, and which is nothing but plus 0. There is no representation for minus 0. So this is again the important property of 2's complement representation of integers. So next we see the another property of 2's complement of a number. So if we calculate the 2's complement of a number, the number is the negative of that particular number. So let us suppose that I have a number plus 8 in decimal. So what will be the equivalent in binary number? This is nothing but 1000, and we will put a 0 to indicate the sign that the number is positive. Now what is the 2's complement of this number? So we will calculate first the 1's complement. So this is the 1's complement of the number. Then we will add plus 1, and that's why we will get the 2's complement representation of 2's complement of plus 8, right? So 1 and 1, this is 0, there is a carry 1. This is 1 and 1, 0, there is a carry 1, 1 and 1, 0, there is a carry 1, so this will become 1 and this will become 1. So 1 1 triple 0 is the representation of a number in 2's complement. So we will see what is the value of this. There is a number, there is some particular number whose representation in 2's complement form is 1 1 triple 0. So what is the value in decimal number system? So we know that the weightage of this is 1, the weightage of this is 2, the weightage of this is 4, the weightage of this is 8, and the weightage of this is minus 16. Now what is the value of the number? Minus 16 plus 8 plus 0 plus 0 plus 0. So this is nothing but minus 8. Minus 8 in decimal number system. So if we calculate the 2's complement of a number, we get nothing but a number which is the negative of that value. Right. And this is the important property of 2's complement representation method. And because of this property, we can do the subtraction using the addition. So let us suppose that I have to subtract a minus b. Instead of doing the subtraction, I can add a plus minus b. So I can find out the minus b from b, and I can add the value of minus b to a. That's why the addition, subtraction can be implemented using addition when we use the 2's complement representation. And because of this, the design of the circuit gets simplified and we have a lot of saving of circuit. Right. So that's why the 2's complement representation method have been used in computer systems since a long time. We see the another important property, shifting right of the number. So when we do the right shift of 2's complement number by k bits, it will divide the number by 2 to the power k. So the vacant position will be filled by sign bit. Right. So let us see the example that if I have plus 7, so the representation of plus 7 is 0 triple 1, and if I shift it right, so this bit will be discarded, this bit will come here, this bit will come here, this bit will come here, and this is the vacant position. So this vacant position will be filled with the sign bit, which is 0. So my number will be 0011. And 0011 is nothing but plus 3. So when we shift the number by 1 bit, it will divide the number by 2. If I shift the bit by k bits, it will divide the number by 2 to the power k. Similarly, if I have the value minus 7, so what will be the representation of minus 7? This will be 1001 in 2's complement form. So if I shift it by 1 bit, so this 1 will be discarded, this 0 will come here, this 0 will come here, this 1 will become here, and there will be a vacant position. So this vacant position will be filled by this sign bit 1. So my number will become 1100. Right. And what is the value of this number? If this number is in 2's complement format, what is the value of this number? This is nothing but 0, 0, 4 minus 8. This is nothing but minus 4. Right. You know how to calculate the value of this number? This has a weightage 1, this has a weightage 2, this has a weightage 4, and this has a weightage minus 8. So this is minus 8 plus 4. So you will get minus 4. So when you divide the number, when you shift it by 1 bit, right, you will divide the number and you will get the result. So this is in decimal number system. So this is actually the important property of 2's complement number representation. Now we see the again other important property of 2's complement of a number. So we can directly represent the 2's complement using a method which is known as the value box method. So we are discussing using a value box method. So what is the value box method? So if I have to represent a certain number, let us say that I have to represent minus 12, which is in decimal. So I want to find out what is the equivalent number in 2's complement in binary. So we can use it value box method like this. Right. So I can use any number of base to represent minus 12. One method says that first you represent plus 12, then you calculate the 2's complement of plus 12, and that's why you get the representation of minus 12 in 2's complement format. But we are representing using the value box method. So when we represent any number in 2's complement format, MSV has a certain weightage. So this is the least significant bit and this is the most significant bit. So this bit will have a weightage 1, this bit will have a weightage 2, this bit will have a weightage 4, this bit will have a weightage 8, this bit will have a weightage 16, and this MSV will have a weightage which is a negative value. Right. Always the MSV has a negative weightage. Right. So how to represent this minus 12 here? Right. So if I write 1 here, it means that the weightage of the number will be minus 32. So I need to add plus 20 to get minus 12. Right. So how I can get plus 20 here? If I have 1 here, if I have 1 here. So this bit will give me the weightage minus 32. This bit will give me the weightage plus 16. This bit will give me the weightage plus 4. So that's why I will get what? Minus 32 plus 20 and which is nothing but minus 12. And rest of the bits will have the weightage 0. So the representation of minus 12 will be 1 1 0 1 0 0. So this using this method we can directly represent any number using the value box method.